Welcome to NextGen Manufacturing Nexus, where we break down the engineering of tomorrow. In the world of aerospace, there's a hidden bottleneck that costs the industry millions and slows down everything from jet fighters to passenger planes. Today, we're solving the autoclave problem.
Okay, take a look at this. It might look like a submarine, right? But it's actually a giant high-pressure oven, and it is absolutely essential for creating the super strong, lightweight composite parts that make modern aircraft possible. Basically, it cures layers of carbon fiber and resin under intense heat and pressure, fusing them all into one incredibly tough piece.
But here is the massive problem. These critical, energy-hungry machines, they're typically underutilized by 40 to 50%. That's just crazy. It's like running a billion-dollar factory at half speed. So why is this happening?
Well, it all comes down to a workflow problem that's been around for decades. It's known as the push system, and it creates total chaos where there should be precision.
In a push system, as soon as a part is ready, boom, it gets shoved towards the autoclave's doorstep. This creates this sporadic, messy arrival of parts, which forces the autoclave to run small, inefficient batches. It's an enormous waste of energy and time. So the first and most fundamental solution isn't some brand new piece of tech. Nope, it's a smarter process. It's all about flipping the entire logic of the production line on its head. Instead of pushing parts forward, a pull system puts the autoclave in charge. See, since it's the bottleneck, the constraint, it gets to pull work towards it, but only when it has the capacity. This simple change transforms the workflow from a chaotic pileup into a smooth, synchronized flow. And what's really fascinating here is how this completely reverses the flow of information. The autoclave is now the conductor of this orchestra, It dictates the pace and sends signals upstream to the rest of the factory. This makes sure that the right parts arrive at exactly the right time to create the most efficient batch possible. And the results? They're absolutely staggering. This simple process change can boost machine utilization by 30% and slash the processing cost per part by up to half. That is a massive win from just a simple, elegant change in thinking. Okay, so we have a better process, but let's take it to the next level. How do you figure out the perfect schedule to pull from? Well, this is where we bring in the digital brain. To really perfect that schedule, engineers use a powerful technique called mixed integer programming. Now, I know that sounds complex, but just think of it as a master Tetris player for the factory floor, figuring out the absolute perfect way to pack parts into each autoclave run to maximize every inch of space and every second of time. This software crunches millions of potential combinations. It weighs every single variable: part size, required cure times, tool availability, even fluctuating energy costs, to generate the most efficient schedule imaginable. It's the digital brain that powers the perfect pull system. But here's the thing, right? Even with a perfect plan, the real world is messy. The inside of an autoclave is a turbulent, chaotic environment, and conditions are never exactly what you expect. A static plan just isn't enough. And this is so important because you need a system that adapts in real time. Inside that chamber, unpredictable airflow can create hot and cold spots. If you're off by just a few degrees, a multi-million-dollar part can be ruined, just gone, wasting a fortune in time and materials. And this is where AI takes the controls. This framework, developed by researchers at Boeing, uses live temperature data from sensors that are peppered all throughout the autoclave. That data feeds into two neural networks, and they work together to build a live, dynamic digital model of what's actually happening to the parts during the cure. Then, a third neural network takes over, and this is just mind-blowing. It runs an incredible 35,000 simulations every single second to find the optimal air temperature needed at that exact moment. It actively adjusts the cure cycle on the fly, acting as an AI co-pilot to make sure every single part comes out perfect every time. So, after all this incredible work to perfect the process, optimize the schedule, and control the cure with AI, what if the ultimate solution is to just get rid of the autoclave entirely? Yeah, there's a radical new trend emerging called Out of Autoclave Manufacturing, or OAA for short, and it's a complete rethinking of how to make these high-performance composites. It's a real game changer. This method uses specialized materials that can be cured with vacuum pressure in just a simple oven. It completely eliminates the need for those massive, high-pressure vessels. I mean, think about what that means. You get way more flexibility, you have lower energy costs, and you can build absolutely massive structures, like an entire wing, without being limited by the size of an oven door. So the big question for the future of composites is this. Do we continue to perfect the bottleneck with smarter processes and AI, turning the autoclave into a finely tuned instrument? Or do we design a future that gets rid of it completely? That's the challenge facing the next generation of manufacturing.